In the last segment, we looked at an example of how to perturb a buffer. In that case, adding some HCl to an acetic acid and acetate buffer. And we saw that we had to split up the problem into two parts, limiting at excess and then solving that equilibrium part. However, one of the things that you likely noted as we did that problem was that as the buffer was reacted, that is, as we added acid in that consumed some of the base, we were slowly moving through our buffer. In essence, we were consuming base. Now, Le Chatelier's principle means that that system at equilibrium reacted back and prevented the change from being too large. But there's clearly some point at which you can add so much acid that you have consumed all of the base, or conversely, you could add so much base that you consume all of the acid half of the buffer. And in either of those cases, we talk about the buffer being exhausted. So when we approach a problem involving adding something to a buffer, it's useful to have a framework for the sorts of possibilities that might happen. So, how do we describe those possibilities? Well, I like to use a vertical axis. So, this vertical axis is describing the total amount of perturbation that's taking place. Right at the center is the place where our buffer is probably working best, close to its pKa. At that position, it will have equal amounts of acid and conjugate base. Now, if we were to add some amount of acid to our solution, we would be raising the pH. Now, as we do so, we are consuming our conjugate base. So, you can imagine that there are 2 points on either side of this where we get to having either all conjugate base or all conjugate acid. That is, adding acid would lower the pH or consume our base, and adding base would consume our acid. So how you solve the problem depends on how much of the perturbing compound is being added. So we can think about adding a large amount, a stoichiometric amount, that is, an amount of strong base exactly equal to the amount of acid. That would bring us up to have just this acid. And we can also think about the adding acid equivalents to each of these. In these regions here, if we only add a small amount of acid or base, well, relatively small, we're still in a region where we're buffering. So the second step that we'll want to take, if this amount that we added is relatively small, will be to solve as a buffer equilibrium problem. Now, if we were to add exactly enough base to consume all of the conjugate acid, we would have only the conjugate base remaining, and we would want to solve this problem as a weak base. The converse is also true down here. If we were to add precisely enough acid to exactly consume all of the conjugate base from our buffer, we would be in a circumstance where we have only the weak acid present. So as you can see already, depending on how much of our perturbing compound we add, there are several types of problems that we could be solving. But we're not quite done yet. There are these cases at the very top and very bottom where we add an enormous amount of either acid or base relative to our buffer. That is, buffers do prevent pH changes, but only up to a point. So in this region, we would say the buffer is exhausted. How do we solve how do we determine the pH if a buffer is exhausted? Well, in that case, yeah, there's a little bit of buffer floating around in solution, but there's also a whole bunch of either strong acid or strong base floating around in solution as well. In that case, the buffer, or our weak acid or weak base, is no longer what's controlling the pH of the solution. The effect of that strong acid or strong base is going to be far greater, and it's going to dominate the pH. As a result, solving either of these cases would be done using the type of strong acid and strong base chemistry that you learned back in Chem 103. In essence, in these cases, you don't even have to do any equilibrium math at all. Now, some important caveats to point out, or related aspects of this. Maybe the most important that I want to point out is that there are 5 possible types of problems that you might solve as a result of perturbing a buffer. You don't know which of these 5 you'll be doing until you have finished doing that limiting and excess calculation. So if something is being added to a buffer and it's reacting, your immediate thought should be, I need to do limiting and excess math. The other thing I'll point out is that these cases, where you add exactly an equal amount, they're pretty rare. That is, you have to be working quite carefully to get this to happen. They could still show up on a test or a quiz, but I would say they're less likely to show up in real lab life. The last thing I want to mention is you'll notice I was careful throughout this to talk about adding a strong acid or strong base to a buffer. It's of course possible in reality to mix together a strong acid with a buffer made from a different conjugate acid-base pair. However, the challenge that will occur then involves calculating simultaneous equilibria. Though that's certainly very doable, it's beyond the scope of what we're going to be covering here in general chemistry. That topic is discussed in much more detail in the course Quantitative Chemistry.